Hi, welcome to this video on writing the conjugate in modulus argument form, and then we'll be writing it in Eulers form. To start off, I'm going to write z as x plus iy. That's our definition of z. Now, you should know the conjugate is simply the same as z, but the imaginary part is turned negative. So we can say z star is equal to x minus iy. Now let me write z in modulus argument form, but without the modulus for simplicity. Here I'm assuming it has just a modulus of 1, but at the end I will explain why the modulus does not change. Now I'm going to write two crucial formulas. If you have never seen these before, just look at the graph of y equals cos and y equals sine and pick a point and reflect it in the y-axis and see what happens, or put some values in your calculator. Now I'm not going to use these yet. First I'm going to write z star as cos theta minus I sine theta, which is just where I've made the imaginary part of z negative. Now using these formulas we know cos theta equals cos of minus theta, and we know that minus sine theta equals sine minus theta. So this is the conjugate of z in modulus argument form. Now I just want to show you on the graph what this looks like. So you can clearly see the conjugate has simply just been reflected in the x-axis, and its angle is negative as it is going clockwise. Okay, well, we know that Eulers form is e to the I theta. Now for the conjugate, theta is actually minus theta, so I can simply replace theta with minus theta in the expression to get the conjugate of z equals e to the minus I theta. Now that's Eulers form done. Okay, and finally for the modulus, what happens to it? Well, we said the modulus is the real part squared plus the imaginary part squared, and then all square rooted. So therefore the modulus of z squared is equal to the real part squared plus the imaginary part squared. So therefore for z, the modulus will be x squared plus y squared. Now let's do the same for the conjugate, and you would look at what we get, x squared plus y squared also. So we know that z and the conjugate of z share the same modulus, and we have negative angles of each other. Okay, well thanks for watching. In the next video I will show you some important properties of the conjugate and how these different forms allow us to write these properties.